damping. So I told you to solve this steps d by dt plus beta, then you have x equals to a exponential minus beta t. So this was the case for critical damping. Do you people remember this step? So this was the case of critical damping. Right? Then I told you to solve this equation, and so that the solution of this equation will be xt equals to at plus b exponential minus beta t, where a and b are some constant and beta you know, that is damping parameter. So how I will proceed? I told you to multiply this equation by exponential beta t. So if you multiply this equation by exponential beta t both sides, what will get? Exponential beta t d by dt plus beta, you have x equals to a exponential minus beta t you have, then you have plus beta t, right? Because if you multiply exponential plus beta t, then you will have exponential plus beta t here. So you will have two terms, minus beta t plus beta t. So it means on the right hand side you will only get some constant a. Now I can further simplify left hand side. So what I can write? I can write exponential beta t, then dx by dt plus beta x, that should be equals to some number or constant. Okay. Further, I can write dx by dt exponential beta t plus beta x exponential beta t, that should be equals to a. Then I can write, see this term, what I can write from this term, can I write like this, the dx by dt exponential beta t plus x into d by dt exponential beta t. I can write, right? If I differentiate exponential beta t with respect to time, exactly I'll get beta exponential beta t. So I can write like this. Now, can anybody tell me what I can write these two terms? Can I write d by dt x exponential beta t? Because you see, if I consider x as a and exponential beta t as a b, so then it will be a kind of product, differentiation of product of two functions. You see, dy dt x exponential beta t. So first you are differentiating x with respect to time. You are keeping exponential beta t as a constant. Second time you are keeping x as a constant, and you are differentiating exponential beta t, right? So I can write left hand side like d by dt x exponential beta t, and that should be equals to a. Is it visible?
Sir.
Yes, sir.
Is it clear now?
Yes, sir.
Okay. Now you can simplify, right? Can you be able to simplify now? Is this step clear, everyone? Is this step clear to all?
Yes, sir.
Okay. So now further I can write from last equation that dx x exponential beta t, that will be how much basically? That will be, so sorry, this will not be x actually, this is actually your t, right? So now further I can write d exponential beta t, that should be equals to a dt. Okay, now I'll integrate. So if I integrate left hand side, what I'll get? If I integrate left hand side, what I'll get? What I'll get? Simply I'll get x exponential beta t, right? And that should be equals to at and sub constant b. So it means x of t equals to at plus b exponential minus beta t. Okay. So this is the solution of damped oscillator under critical damping. Please note that this is not the part of your post oscillator. This is actually a part of damped harmonic oscillator. So I gave that homework under critical damping. You have to prove this, right? But nobody has able to solve this. So that's why I have done this. Is it clear?
Yes, sir.
And
Yes.
I have given this homework because similar kind of formula or logic I have to apply when I'll solve that radioactivity part, that is method of successive transformation. So anyway, if you have understand this step, then it will be easy in that part. Okay. So is it now clear, right? Now you can understand, right?
Yes, sir.
Okay. Now is this function oscillating in nature? Is this function oscillating in nature? No, right? Because it doesn't contain any sine or cosine function, right? So whatever that we already have discussed, that this function has not contain any sine or cosine function, and these are not obviously these are not oscillating function. What is the meaning of oscillating? So it will increase, then decrease, increase, decrease like this. But this is not a oscillating function. This is your straight line function, or this function will increase monotonically, right? And this is a kind of exponential decay function. So under critical damping, whatever we have discussed, there is there will not be any oscillation. Okay, these things we already have discussed in that in damped oscillator case, right? Okay. Now another homework I have given, very less people has done this homework. So I have given that inductance value. How much it was? Inductance value I have given that is 0.1 Henry, right? And I have given capacitance value that was 2 microfarad, means 2 into 10 to the power minus 6 farad, right? And also I have given resistance value, that was how much? 2 ohm. So few people has done this homework, but most of them has not done. Also I have checked, few of them has made a mistake. So I'll solve. Please check your calculation. So that formula is very easy, right? So you know that discharging of capacity that LCR circuit behaves like a damped oscillator, right? So we have already seen that in that case, that frequency of oscillation was how much? That was basically 1 by LC. Then you have minus R square by 4 L square, right? So this was your case. Okay. Now if you substitute this value, so you have L value is how much? 0.1, and you have C is how much? 2 into 10 to the power minus 6. And R square, R you have 2, so R square means 4 divided by 4 into L square. L square is how much? 0.1 means 10 to the power minus 1. So L square means 10 to the power minus 2. Okay. So it's a very simple calculation, but very less people has solved it and shared me. So if you solve it, approximately you will get that frequency, angular frequency of oscillation is around 2236, okay, radian per second. Okay. Anyway, yesterday I gave homework, okay. That also nobody has done, but today you please try it, okay. If you are not able to solve, tomorrow I'll solve it. So that homework I have given, I told you that at p equals to 0, you will get maximum value of amplitude. Okay, and p equals to square root of omega naught square minus twice beta square. Okay, at this p you will get minimum amplitude. ओके, सो आप लोग फिर से आज ट्राई करो, अगर नहीं हुआ तो फिर मैं कल सॉल्व करूंगा इसको, ठीक है। आज एक बार ट्राई करो फिर से।
ओके सर। कैलकुलेट क्या करना है इसमें?
सॉरी,
कैलकुलेट क्या करना है इस क्वेश्चन में?
ओके, सो यू आर देयर, यू आर प्रेजेंट इन दैट लास्ट क्लास, राइट? कल आप क्लास में थे?
सर थे।
Okay, so I told you that we have solution, right? Solution of force oscillation, that was a sine of pt minus theta, right? This was your solution. So we have obtained the value of amplitude, right? A is nothing but the amplitude of oscillation, right? Under force oscillation case. So then we have obtained two values of p. In that value, either you will have maximum of A or minimum of A. I mean, at p equals to 0, आपको क्या प्रूव करनी है कि at p equals to 0, you have to show that the amplitude of oscillation will be maximum. Sorry. At p equals to 0, amplitude of oscillation will be what?
Minimum.
Minimum value. This will be minimum value. This will be minimum. And at this case, you will get maximum amplitude. In this case, you will get maximum amplitude. तो ये जो आपका एम्पलीट्यूड है ना पोस्ट ऑसिलेशन में, when p is 0, what is p? What is p? What is p?
Dissipation power.
Anyone?
Power dissipation. Driving frequency.
Yes. So there are two p in that discussion, right? One is small p, always we are dealing with. Small p means driving frequency, right? So p is nothing but driving frequency. Okay. So this p actually. So when p equals to 0, you will get minimum value of amplitude of oscillation. When driving frequency equals to square root of omega naught square minus twice beta square, then you will get maximum value of amplitude. Okay, so you have to please try it today itself. If you are not able to solve, tomorrow definitely I'll do. Okay.
Sir.
Okay. Now is it clear? What was the question? Is it clear now?
Sir.
Okay. Okay. So yesterday we have discussed that power dissipation, right? We have discussed about that power dissipation. Now we'll discuss about the power absorption. Okay. तो आप लोगों को तो समझ में आ रहा है क्लास में, फिर आप होमवर्क क्यों नहीं कर रहे हो आप लोग? जब भी मैं पूछता हूँ आप लोगों को तो आप लोगों को समझ में आता है। अब स्मॉल पी को आप लोग बोल रहे हो पावर डिसिपेशन, है ना? कल का ही डिस्कशन था ये, है ना? कैसे काम चलेगा बताओ, है ना? आपका सामने एग्जाम है, आपको मेहनत करना है ना। और मैं तो हमेशा बोलता हूँ ना, आप क्वेश्चन करो ना जितना पॉसिबल है, वो तो अच्छी बात है। आप क्वेश्चन करोगे तो इतना स्मॉल मिस्टेक नहीं होना चाहिए क्लास में। Okay, now we'll discuss power absorption. Okay, let us denote it like P subscript A. Okay, so power dissipation, the cause of power dissipation was damping force, right? So damping causes there is a friction, and friction causes there is a loss of energy, and that rate of loss energy was the power dissipation. Now the source of power absorption is actually the driving force, because you are actually externally supplied that force, driving force. So power absorption, the cause of power absorption is, or you can say the source of power absorption actually the damping force, sorry, external force, driving force, exactly. So what I can write, PA, that will be how much? You know, power is nothing but force into velocity, right? So in that case, what I'll write, what force I will use? Driving force. And driving force was how much? F naught sine of PT, right? That was your driving force. And velocity, then I'll take. Okay. Now we know that velocity, right? What was that velocity? Can anybody tell me? What was that expression for velocity? So it was F naught P, right? F naught P, then you will have cos of PT minus theta divided by square root of omega naught square minus P square whole square plus 4 beta square P square. So this is your power absorption. So if you further rearrange, so you will get F naught, small f naught, then you have P, okay, then sine of PT. Now I can write in place of cos PT, I can write cos PT, sorry, in place of cos PT minus theta, I will use cos A minus cos B formula. So that is nothing but cos PT cos of theta plus sine PT sine of theta. And you have, of course, in denominator you will have square root of omega naught square minus P square whole square plus 4 beta square P square. Okay, this part clear? Is it clear? Nothing I have done.
Yes.
Just I have written cos PT minus theta. So cos A minus B, that is nothing but cos A cos B plus sin A sin B. Okay.
Yes, sir.
Okay. Okay. Now I'll introduce the sin PT inside this bracket. So if I insert sin PT here, or let me write in another line. So I'll erase this part first. It will be if not P, then if you insert that sin pt, so you have sin pt cos pt, right? So if I write in place of sin pt cos pt, can I write 1 by 2 into sin 2 pt?
Yes, sir.
Because you see, I can write 1 by 2 into twice sin pt cos pt or cosine pt into you have cos theta, right? And in the second term, you will get, of course, sine square of pt, then you have sine theta. Okay, divide by square root of omega naught square minus p square whole square plus 4 beta square p square. ठीक है? So this thing I can write 2 sin a cos b. That is nothing but what? Sin 2 pt, right? So I can write in place of this, I can write what? In place of this, I can write sine of 2 pt, sine of twice pt. Okay. Okay. So this is your power absorption, right? Now if I take time average of power absorption, or let me write in another line. So time average of power absorption will be how much?
Sin 2 pt 0 हो जाएगा.
So if not small f not p, that will be same as it is, of course. And आपका डिनोमिनेटर में जो फैक्टर है ओमेगा नॉट स्क्वायर माइनस पी स्क्वायर होल स्क्वायर प्लस 4 बीटा स्क्वायर p square, that will be same. Now this will be how much? Time average of sine function is how much?
0.
Everybody, बाकी सब लोग बताओ कितना होता है टाइम एवरेज?
0, sir.
0 होता है, right? So this term will be 0, right? So this term will be 0. So what about this term?
1 by 2.
Because
Sine square
yes,
1 by
exactly, it
2.
will be 1 by 2. Of course, it will be 1 by 2 into sine of theta, right? You have sine theta also. So when I am taking time average, so this function sine theta will be treated like a constant factor because I am dealing with only time average, right? So I have to take time function. Is it clear? Is it clear what I'm trying to say?
Yes, sir.
Because when you are taking time average, it means you are integrating with respect to dt, right? So if you are integrating with respect to dt, of course, in that scenario, sine theta will be treated like a constant. Is it clear?
Yes, sir.
Yes, sir.
Okay. Okay, now how will calculate that sine theta? So if you remember, so you have f naught cosine theta was how much? Sorry, f naught, yes, f naught cosine theta was how much? Anyone? So it was omega naught square minus p square into a, right? कॉपी चेक करो कल की, कल वाला लेक्चर चेक करो आप लोग. And f naught sin theta, it was how much? Twice beta pa, right? Whatever we have discussed yesterday. So f naught cos theta was like this, and f naught sin theta was twice beta pa. So from this equation, if I divide this equation by this equation. So what I can get, what I'll get, tan theta will be how much? Tan theta will be how
Beta
much?
p upon omega naught square minus p square.
Twice beta p divided by omega naught square minus p square, right? This will get tan theta. So if I draw a triangle, so it means this actually representing perpendicular, this will be base, right? So if I draw a triangle, so its base will be how much? Omega naught square minus p square. Its perpendicular will be how much? Twice beta p, right? So hypotenuse will be how much? This will be the hypotenuse. Okay. So this hypotenuse will be how much? Square root of omega naught square minus p, sorry, p square whole square plus 4 beta square p square, right? And this is the theta. So tan theta means perpendicular divided by base, perpendicular divided by base. So I can calculate hypotenuse. So this will be the hypotenuse, just square of this plus square of this. Then you have to take square root. So this is actually theta. So I can calculate sine theta. Right? Now I can calculate sine theta. Sine theta will be how much? Simply 2 beta divided by this. Sine theta will be how much? 2 beta divided by, sorry, 2 beta p divided by square root of omega naught square minus p square whole square plus 4 beta square p square. Now I'll use this value in this power expression. So now average power will become, or average power absorption, that will be simply F naught, small f naught, then you will have what? We have P also, right? Then you have P 1 by 2 in place of sine theta. What I'll use is value. Value will be how much? 2 beta P divided by square root of omega naught square minus p square whole square plus 4 beta square p square. And you already have, what you have already? Omega naught square minus p square whole square plus 4 beta square p square. Okay, and its square root is there. So these two will be cancelled. Okay. So finally we'll get now capital F naught, that is force amplitude, that I can write in terms of small f naught. So if I write small f naught, so capital F naught is nothing but m into small f naught, right? So if I substitute this value, I'll get m f naught square, and you have p here, p here. So it will be p square beta. Okay, beta you have, and here square root. So it will be that square root will be cancelled because two terms are there. So of course square root will be cancelled. You will get omega naught square minus p square whole square plus 4 beta square p square. So this is the time average of power absorption. Okay. Now what will be the
1 by
maximum?
4 का फैक्टर भी होगा ना शायद
1 by 4 का फैक्टर
हाँ
कहाँ पे?
डिनोमिनेटर में
क्यों?
सर 4 कैंसिल नहीं हो रहा ना 1 by 2 and 2 कैंसिल हो रहा है एंड एक 4 पहले भी था ना पी एवरेज वाले टर्म में
No, I don't think there is 1 by 4 is there. No.
ओके सर मुझसे कुछ गलती हुआ होगा
हाँ हाँ नहीं 1
Okay,
by
sir.
4 नहीं था, एक्चुअली 1 by 2 था.
ओके सर
हाँ. Yes. Now the question is, at what value of driving frequency that power absorption will be maximum? Yes. at what value of driving frequency the power absorption or average power absorption will be maximum. How will proceed?
तो differentiate करेंगे.
You can differentiate or you can apply some logic also. So now if I divide by p square, so what I am saying, if I divide p square on numerator and denominator, so what I'll get, m f naught square. Of course you can do differentiation that method also, but this method is also logical. So this thing I can write like this also. So if I divide by p square, so what I'll get, m f naught square beta divided by omega naught square minus p square whole square divided by p square, and you have 4 beta square also, right? Now आपका पावर मैक्सिमम पावर एब्जॉर्प्शन होने के लिए क्या होना पड़ेगा, इसको मिनिमम होना पड़ेगा,
Denominator
right?
में.
So this
Okay.
will be minimum only when this term will be minimum, right? And this, the minimum value of this is only that minimum value can be how much will be the minimum value? Because you see, this term can never be negative because इसमें आपका स्क्वायर है और p square भी है, and also p is driving frequency, it cannot be negative. So what I am trying to say, this term can only be positive number. ठीक है ना? अब इसको मैक्सिमम होने के लिए इसको मिनिमम होना पड़ेगा, अब मिनिमम होने के लिए इसको मिनिमम होना पड़ेगा, ये तो सम कांस्टेंट है. अब इसका मिनिमम वैल्यू कितना पॉसिबल है, 0 ही पॉसिबल है, क्योंकि ये तो सम पॉजिटिव नंबर ही देगा हमेशा. Only smallest positive number that is possible, that is 0, and 0 is possible when p equals to omega naught. Zero is possible only when p equals to omega naught. Is it clear? Because these things, whatever is in the denominator, that should be minimum for maximum value of power, right? And this is minimum only when this term will be minimum, because you cannot tune this term. This is some constant. So this term is minimum, and that minimum can only be 0, because this is a whole square and this is a p square. So this will always give you some positive number, and minimum that can give you, that is 0, and 0 is possible only when p equals to omega naught. Okay, so when p equals to omega naught, then you will get maximum power absorption, and that will be, okay, please write it capital P, okay, because small p is basically your driving frequency and capital P means power. So maximum power absorption or time average of maximum power absorption, that will be how much now? So this term will be 0 now, because you are substituting this value, right? P equals to omega naught. So this term will be 0. So how much you will get? M f naught square beta divided by 4 beta square. So beta will be cancelled, on beta will be cancelled. You will get m f naught square divided by 4 beta. M f naught square divided by 4 beta. So this is the maximum power absorption or time average of maximum power absorption. And this condition P equals to omega naught, this is known as what? Anyone? Resonance, right?
Yes, sir.
Okay. Is this part clear?
sir.
Yes, sir.
किसी का कोई डाउट है यहाँ तक? Is there any doubt?
P is equal to omega naught resonance मतलब.
Yeah,
Yes,
you are
sir.
asking this.
Yes, sir.
So this is your expression for time average of power absorption, right? This is the expression for time average of power absorption. Now I am asking at what value of driving frequency that power absorption will be maximum. So इसको power absorption इसको maximum होने के लिए क्या होना पड़ेगा? इसको minimum होना पड़ेगा, right? So minimum होने के लिए ये तो p के ऊपर independent है, this term 4 beta square, right? So this term contain p, right? Now you see omega naught square minus p square whole square, that can never be negative, right? And of course you have p square here also. So what I'm trying to say, this term can never be negative. अल्टीमेटली आपको ये टर्म को क्या होना पड़ेगा? मिनिमम होना पड़ेगा। अब मिनिमम होने के लिए क्या होना पड़ेगा? इस टर्म को मिनिमम होना पड़ेगा। अब ये टर्म तो आपका नेगेटिव नहीं हो सकता है, तो कुछ पॉजिटिव नंबर मिलेगा। अब पॉजिटिव नंबर में से सबसे मिनिमम क्या है? 0 है, तो 0 ही मिनिमम, 0 ही आपका क्या देगा? पावर को एब्जॉर्प्शन का मैक्सिमम पावर एब्जॉर्प्शन देगा। अब 0 कब पॉसिबल है? जब p इक्वल्स टू ओमेगा नॉट। देखो p इक्वल्स टू ओमेगा नॉट सब्स्टिट्यूट करो, ये 0 हो जाएगा। नाउ इज इट क्लियर?
Yes.
Okay.
Yes.
Okay. So this condition is known as resonance. Okay. Now if you plot driving frequency as a function of, sorry, power absorption as a function of driving frequency, then how it will look like? It will look like this kind of plot. So this is the point. So this point corresponds to p equals to omega naught. And at this driving frequency, you will have maximum value of average power absorption, and that will be how much? P average or P absorption average maximum. Okay. Now let us define half of the maximum power absorption. So let us define this point, and that point corresponds to the height. That height is basically PA average maximum by 2. तो ये हाइट मैंने मैंने हॉरिजॉन्टल लाइन ड्रॉ किया। ये जो हाइट है कितना है? इसका हाइट है पी एवरेज मैक्सिमम का आधा है। ये तो आपका हाइट, ये जो हाइट है मैक्सिमम हाइट का आधा है। अब इस हाइट के कॉरस्पॉन्डिंग देखो दो आपका ड्राइविंग फ्रीक्वेंसी मिलेगा। दिस फ्रीक्वेंसी लेट अस डिनोट दिस इज ओमेगा 1, and this frequency let us denote this is omega 2. Okay, is this part clear? So if you plot that average power absorption as a function of driving frequency, you will get this kind of plot. Okay, so the driving frequency at omega naught, you will have maximum power absorption. And let us define some point or horizontal line. The height of this line is actually P average, मतलब क्या है? Half of the maximum power absorption. So corresponding to this line, you will have two driving frequency. One is omega 1, another is omega 2. Now we'll discuss the bandwidth of resonance. So what is bandwidth of resonance? What is bandwidth of resonance? So bandwidth of resonance is nothing but difference in the driving frequency. Difference in the driving frequency at which power absorption becomes half of its maximum value. Difference in the driving frequency. Difference in the driving frequency means, let us take omega 1 and omega 2. At this driving frequency, the power absorption become half of the maximum value, right? I mean, at omega 1, you are getting half of the power absorption, I mean maximum value, half of the maximum power absorption. Also, at omega 2, you are getting power half of the maximum power absorption. So bandwidth of resonance is nothing but omega 2 minus omega 1. So again, I'm repeating that sentence. Bandwidth of resonance is nothing but difference in the driving frequency at which power absorption becomes half of its maximum value. Now, how will calculate this? How will calculate this? Can we able to calculate? So we already know that expression, right? Time average of power absorption equals to, I mean, at bandwidth of resonance, what I will write? The time average of power absorption will be a half of time average of power absorption max, right? So here we know that expression for this. That expression was how much? Am f naught square, then beta p square, right? Then you have omega naught square minus p square whole square plus 4 beta square p square. This was your expression, right?
Yes, sir.
This was your expression for power absorption. And 1 by 2, what was that expression for maximum power absorption? Time average of maximum power absorption. That was
M f naught square by 4 beta.
exactly. So m f naught square divided by 4 beta. So m f naught square will be cancelled, right? So if you solve it or if you rearrange it, how much it will get? So this is 8 beta. If you bring this side, it will become 8 beta square p square. So what I can write, 8 beta square p square, that should be equals to omega naught square minus p square whole square plus 4 beta square p square. Further, if you rearrange it, you will get omega naught square minus p square whole square, that should be equals to 4 beta square p square. It means omega naught square minus p square, that should be equals to how much? Plus minus 2 beta p. Okay. So it means omega naught. So I can write omega naught square minus p square, that will be omega naught plus p into omega naught minus p. So I can write like this, omega naught minus p into, or I'll write in the right hand side. So I can write like plus minus 2 beta p divided by omega naught plus p. I can write, right? Is it clear? Is it clear? Now if I divide by p, so what I'll get? I'll get like this. Right?
Yes, sir.
Now see, this point is omega 1, this is your omega 2, and this point corresponds to p equals to omega naught, right? So these points are close, you know, omega 1, omega naught, and omega 2. These points are very close. These points are very close. So when we are calculating that bandwidth of resonance, so P we are actually what we are substituting, P value will be how much? Either omega 1 or omega 2, right? And they are actually very nearer to omega naught. So we can approximate like omega naught by P, that will be close to unity, because these points omega 1, omega naught and omega 2, that are very close. So we can approximate omega naught by P, that should be equals to 1 or close to unity. So if I approximate it, I'll get plus minus twice beta by 2. So you will get basically simply beta. So omega naught minus P, that is plus minus beta. Now when it will be plus beta and when it will be minus beta?
Omega 2 it will be plus beta.
When we'll take P equals to omega 1, when we'll take P equals to omega 1, then of course omega naught minus omega 1, that will be some positive number, right?
Yes, sir.
Because omega 1 actually on the left hand, omega 1 किधर है आपका? omega naught बड़ा है as compared to omega 1. So when you will take driving frequency equals to omega 1, in that scenario you will get omega naught minus omega 1, that should be equals to beta. So what I am trying to say, omega naught minus omega 1, that will be equals to beta. Okay, when you will take P equals to omega 2, then you will get omega naught minus omega 2, that should be equals to minus beta. Because omega 2 is large as compared to omega naught, right? So of course this value will be negative, right? So that's why you have to take minus sign. So it can be plus or minus. When you will take P equals to omega 1, you will get plus beta. When you will take P equals to omega 2, you will get minus beta. Now you can calculate that bandwidth of resonance, right? So how much it will be now? So what will be the expression now? Bandwidth of resonance. Yes. कितना होगा? So bandwidth of resonance is actually what?
Omega 2 minus omega 1 by
Omega 2 minus omega 1, right? Difference in the driving frequency at which power absorption become half of its maximum value. मतलब आपका omega 2 minus omega 1, that is actually your bandwidth of resonance. So you got two equations. From here you can calculate bandwidth of resonance. So if you subtract this equation minus, if you do this equation minus this equation, of course you will get omega 2 minus omega 1, right? So omega 2 minus omega 1 will become how much?
2 beta.
Beta.
Twice beta, right? And twice beta is how much basically in terms of relaxation time? That is nothing but 1 by tau. So bandwidth of resonance omega 2 minus omega 1, that is nothing but 1 by tau. Is it clear? Is this clear?
Yes.
Okay. So this is all about your force oscillation. So if you have any question, you can ask me. Do you have any question, anyone?
Yes.
No question, right? आप लोगों को समझ में आ रहा है क्लास में
sir.
सबको?
Yes, sir.
अच्छा, आर यू एंजॉयिंग क्लास? आज का सारी चीज समझ में है आप लोगों को?
Yes, sir.
Yes, sir.
Okay.
Yes.
This topic is new for all, right? Force oscillation. आप लोगों ने पहले किए हो इसको?
नहीं सर.
No, right?
No, sir.
Okay. So one homework is remaining. Please try it today. Okay. एक बार और ट्राई करो आप. अगर नहीं हुआ फिर मैं कल करूंगा. ठीक है?
Yes, sir.
Okay.
Yes, sir.
Okay, then we should leave here.
वर्कशीट प्रॉब्लम भी
Sorry,
सर असाइनमेंट कौन सा है?
असाइनमेंट अभी जो आप लोगों को बोला था ना कि at p equals to 0 you have to show that amplitude of oscillation you will get minimum value, and p equals to square root of omega naught minus twice beta square. At this driving frequency you will get maximum amplitude of oscillation. That you have to prove. Yesterday I gave that homework. You have not done it. Please try it today. Okay, that homework I am asking. Okay.
सर
Yes.
सर ग्राफ के लेफ्ट साइड में सर ओमेगा 1 जो गिरा है सर ग्राफ से नीचे सर, तो वहां पे भी एवरेज, ये सर उसके ऊपर सर ग्राफ से जो गिरा है सर,
ये
यहाँ पे सर, वहां पे सर मैक्सिमम वहां पे भी होगा सर, हाफ मैक्सिमम सर एवरेज।
हाँ, ये आपका हाफ मैक्सिमम है, मतलब हाँ मैक्सिमम का आधा है ये जो हाइट
सर
है।
ओमेगा 1 पे भी सर।
हाँ देखो, ये तो एक पर्टिकुलर पॉइंट है। आप कोई भी फ्रीक्वेंसी ले, मतलब कोई भी हाइट ले लो, इसका अराउंड, इसका नीचे कोई भी पॉइंट ले लो, है ना,
ये सर,
मतलब
तो सर सर तो ओमेगा इक्वल ओमेगा 2 होना चाहिए सर, ओमेगा 1 इक्वल ओमेगा 2 होना चाहिए फिर तो सर।
नहीं, कैसे होगा? ये दोनों पॉइंट तो अलग अलग ड्राइविंग फ्रीक्वेंसी पे है ना, कैसे होगा? नहीं होगा।
ओके सर।
बैंडविड्थ ऑफ रेजोनेंस का जो कॉन्सेप्ट तो वही है ना, that concept itself is saying the difference in the frequency at which the power absorption becomes half of its maximum value. मतलब दो डिफरेंट ड्राइविंग फ्रीक्वेंसी में आपको सेम पावर मिलेगा, ठीक है ना। नॉट ओनली दिस पॉइंट, कोई भी पॉइंट ले लो आप, कोई भी आप एक पार्टिकुलर वैल्यू ले लो पावर एब्जॉर्प्शन का, उसका कॉरेस्पॉन्डिंग आपको दो ड्राइविंग फ्रीक्वेंसी मिलेगा। आप चेक करो, कोई भी हाइट एक ड्रॉ करो, देखो आपको ड्रॉ ड्राइविंग फ्रीक्वेंसी मिलेगा। बट बैंडविड्थ ऑफ रेजोनेंस का जो कॉन्सेप्ट है वो सिर्फ हाफ ऑफ द मैक्सिमम पावर एब्जॉर्प्शन के लिए है। तो आपका ओमेगा 1 एंड ओमेगा 2 इट इज नॉट सेम, यू कैन क्लियरली सी दिस पॉइंट एंड दिस पॉइंट इज नॉट सेम। ओके
ओके सर।
ओके, वी शुड लीव हियर।
थैंक यू सर।
वेलकम।